Welcome back. Today we'll be implementing the linked list version of a queue. Our queue will be a generic queue which can use any data type. So, the first thing that we'll implement is a private class called node. So, node will have two members. The first member is data and the next member is next. So, the next member, next, is a self-referential member. So, data basically stores the information that we'll need. So, since queue is a data structure, and a data structure, what does it do? Store data. So, data will store that data that we need to keep. And next points to the next node within the queue. So, since it's a linked list implementation, next is practically a link between the next node. So, what we're going to do here is some getters and setters. So we're going to do the constructor first, and then we're going to do some getters and setters, which really don't need any explanation. So for the next couple of minutes, I'll be silent. By the way, for all you guys that are wondering, this IDE is the Eclipse IDE for Java. You can look online and download it and set it up. So we're finished with the private class node. So now we're creating our members for the queue itself. So we have front and rear like in the array implementation of a queue. So if you watch my last video on the array implementation of a queue, front and rear should not be new to you. Also, the size variable should not be new to you. The size variable basically keeps track of the current size of the queue, or the current number of elements within the queue. So we're going to do our constructor now. So we're going to do the default constructor. Within our default constructor, we're going to set front and rear to null. When front and rear equal null, this means the queue is empty. Since there's nothing within the queue at this current moment, then the queue is empty. We're going to set size equal to 0 since the queue is empty and there's no element within the queue. So the next method we'll do is empty. Is empty checks if the queue is empty. And this is a pretty straightforward function. So the test condition is if front is equal to null and rear is equal to null, then the queue is empty. So we return true when front equal null and rear equal null. Otherwise, we return false. I promise you, it cannot get any simpler than that. Now, our next operation is get size. Get size returns the size of the queue. Pretty straightforward function. This is practically a getter or an accessor if we like to use a technical term. So we're going to use the onQueue method now, or create an onQueue method. The onQueue method, using a technical term, is practically a mutator. So we're going to create our new node to insert within our queue. We're going to pass it the data type that we'd like to store, and we're going to set the next portion to null to indicate that the new node does not point to anything as yet. So we're going to test if we successfully allocated memory. That's why we're testing if temp equal null. If temp equal null, then obviously we did not successfully allocate memory, so we'll return from the function. If we successfully allocated memory, then we can just continue. So we're testing for a corner case right here, or an edge case. So when the queue is empty, this means there's only one element. So at this time, front and rear will both point to temp, and this is the only time. Now, if the queue is not empty, then what happens is that rear set next points to temp. So temp now becomes the last node within the queue, and then we'll set rear equal to temp. As you can see, rear now points to temp, which is the last node within the queue. So we return true because we successfully just inserted a node. About for a moment, but as you can see, I did it by incremented size, which shows that an item was inserted. Now for the DQ method. The DQ method is pretty simple as well. So remember, the DQ method we can only remove from the front. So we're going to test if the queue is empty. If the queue is empty, then obviously we cannot DQ anything, so we'll return none right away, which represents that there isn't anything within the queue. So, and now if the queue is not empty, we store the data that is contained within the first node within item. Afterwards, I'm going to create a temporary front and store the next node within our queue in temporary front. So I'm sorry, there's some error right there. I'm going to make some changes right away. So the DQ method has something wrong with it. So we have a special case or corner case to deal with. The corner case is when there's only one element within the queue. When there's only one element within the queue, we must make sure that front and rear are both set to null to signify that the queue is empty. As you can see on screen, I didn't do that, so there's an error right there currently. But later down, I'll fix it and I'll show you when I fix the error. So that's basically it for now for the DQ function. So you see me make some corrections later on. So the next function or method is destroy. Destroy is straightforward. Destroy basically destroys the entire queue. So to destroy the entire queue, we'll basically be calling DQ over and over and over until we get a null value or until the queue is empty. If we get a null value, that signifies that the queue is empty. So that's basically the destroy. method. But on screen, we did not do that. We used a different version, a more inefficient version. Sometimes when you're typing, you type something that is inefficient, and only after looking at it, you could say, oh, I could cut this code down to a few more lines. So that's what happened. But later on, you'll see the different version of that code. So that's basically it for now. And that's it for that video. Thank you. Thank you for not falling asleep. Thank you for watching this video. Thank you for giving me a like. Thank you for subscribing. Thank you for everything, man. You're the reason why I do these videos. Have a good day. Hopefully I could help you.